You know, every time you send a message, stream a movie, or just browse the web, you're tapping into this invisible system that powers our entire digital world. Today, let's break down that very system, the unseen engine of the internet itself.
I mean, have you ever really stopped to think about it? What actually happens when you hit send? You type out a message, maybe you attach a photo, you click that button, and poof, it just vanishes. It feels completely instant, right? But underneath that one simple click, there's this wild, fascinating journey taking place. So what's really going on?
Well, it all comes down to a set of rules. Think of it like a universal language that basically every connected device in the world is agreed to speak. It's called the TCP/IP protocol suite. And honestly, it's the unsung hero of our digital lives.
Okay, so to really get how this language works, we've got to look at its blueprint. The best way to think about TCP/IP is as a four-layer roadmap. This is the exact map that guides every single byte of your data from your screen all the way to its final destination.
The journey for your data always starts at the top, at the application layer, and then it works its way down. It's like an assembly line. First, your data gets prepped for the trip, then it gets an address slapped on it, and finally, it's sent out into the wild. And get this, once it arrives, the whole process just happens in reverse. So let's follow that path step by step.
All right, let's make this super concrete. Let's say you're sending just one photo to a friend. Before that photo can zoom across the internet, it has to be packaged up just right for the journey.
The whole trip kicks off right here at the application layer. This is the part you actually interact with. Think your email app, your web browser, whatever you're using. This layer grabs your photo and uses the right set of rules, what we call a protocol, like SMTP for an email, to get it all prepped.
Okay, once it's prepped, your data gets handed down to the next level, the transport layer. I love this analogy. Think of this layer as the quality control manager. And it has a really important decision to make. What's the best way to send this photo?
And this is where things get super cool. The manager has two main options, TCP or UDP. Now for our photo, we need every single pixel to show up perfectly, right? No missing bits. So we're going to use TCP. Think of TCP like a certified bank transfer. It's a bit slower, but that's because it does this thing called a three-way handshake. It's literally your device saying, "Hey, you there?" The server saying, "Yep, I'm here," and your device saying, "Great, here comes the data." It makes sure the connection is solid before anything is sent. Now, UDP is the complete opposite. It's the wild child. It's all about speed. Think of a live video stream. UDP just fires the data out as fast as it can. If a few pixels get lost along the way, who cares? You barely notice. The stream just has to keep going.
So we've decided how to send the photo reliably with TCP. Now we have to figure out where it's going. And that's the job of the internet layer. This layer is basically the digital post office. It takes our data and slaps a big ol' shipping label on it, the IP address. That's the unique, one-of-a-kind address for your friend's device. You know, this whole process of moving down through the layers and adding more information has a name. It's called encapsulation, and it's kind of like a set of Russian nesting dolls. You start with your photo, that's the data. Then the transport layer puts it inside a TCP header. Now it's a segment. Then the internet layer puts that inside an IP header. Now it's a packet. And finally, the network access layer wraps the whole thing up for its physical journey, turning it into a frame. See? Each layer adds its own little envelope. And when it gets to its destination, your friend's device just unwraps these layers one by one to get back to the original photo inside.
All right, our photo is all packed up, it's got an address, it is ready to go. Time to hit the digital highway.
And this is where the digital becomes physical. It's pretty amazing, actually. That final layer, the network access layer, takes that neat little frame and turns it into an actual physical signal. We're talking electrical pulses zipping down an Ethernet cable, or radio waves floating through the air for Wi-Fi. And just like that, it's officially on its way. Okay, so we've just followed the incredible journey of one single photo. But, so what? Why does this whole complicated four-layer dance actually matter to you and me?
Well, because it is the engine behind literally everything you do online. Think about it. That fast-paced online game you love, that's screaming along using UDP for maximum speed. That secure banking app you trust with your money, you better believe that's using rock-solid TCP for reliability. Video calls, cloud storage, just browsing the web, sending an email, it's all built on this exact same four-layer foundation.
Of course, whenever you have a system this universal, this open, security becomes a huge deal. I mean, with all this data flying around on this massive digital highway, how do we keep it all safe?
That's where some tools you've probably heard of come in. Think of a firewall. It's like a security guard for your network, checking the ID of every data packet trying to get in or out. And a VPN? That's like building a private armored tunnel for your data to travel through, making it totally invisible to anyone trying to peek. They're basically the guardrails and secret tunnels of the internet.
So, here's the big takeaway. TCP/IP is so much more than just a technical thing. It's really the fundamental agreement. It's that digital handshake that allows billions of completely different devices to talk to each other seamlessly. And the absolute genius of its layered design is how flexible it is. You can invent some brand new super fast Wi-Fi tech or a new app, and you don't have to rebuild the whole internet from scratch. Each layer just does its one job, trusting the other layers to do theirs. It's the system that holds our entire connected world together.
And that brings us to a really big final thought. This whole system, TCP/IP, was created way back when by researchers in an environment of, well, trust. It was designed to connect people and share information openly. But the internet of today, it's a very different world, right? So it leaves us with a question to chew on. In an era where there's so much mistrust online, how do we protect the original foundational promise of this incredible system for the future?